start. So, I guess that on Tuesday I decided that I was going to do sensory physiology today. I'm planning on actually updating your muscle physiology PowerPoint. I think that I'm going to reduce the amount of slides just to make it possible for me to actually finalize and cover everything that you need to know in the next two sessions or next week. So today we're going to do sensory physiology. I think that it's important for us to in a way finalize the nervous system with this. Your homeworks and everything should be available for you guys. I guess that after lecture, you should have access to everything. I guess by 5 today or right after lecture. Okay, regarding the chapters that we have already covered. All right, so let's do this. Are there any questions right now? We're good. Yes. How old are you? You're 21. 23. I know that you're, I don't know, 20 and you're 21 and you're going to party like crazy today. You can actually legally drink, right?
We did.
All right, so there are a few things that we need to know about the sensory system. We're not going to get into all the details regarding the special senses. I think that on your syllabus you have the specific pages that you have to cover regarding this chapter. This chapter would be, if we get into the special senses, we'll need an extra month to actually cover them. So we're only covering the basics of this chapter. We're not going to do the special senses physiology. All right, so let's do this. So basically we're talking about the sensory system. Don't forget that the sensory system receives information from what's on the periphery, right? And we all, as you can see, we all interpret things differently. We all have a different perception of things, right? Normally, that information is processed by your brain, and I'm going to give you a few examples now, I think. So we're talking about the sensory system, and what we're going to cover today is the somatic and proprioception involved in the somatosensory system. The other special senses, as I just mentioned to you guys, we are not going to cover. So proprioception is a term that we have already covered, correct? Yes? And you know what proprioception is. You need to know what proprioception means. All right. So I'm just giving you an example there. What do you perceive there? What's square? Yes? Vagueness?
Yeah.
If you really think that there is a square there, I don't see it. I just see 4 little incomplete circles there, and I completely agree that I can see backwards here. There is here, right? We all interpret this differently, right? And I don't know, somebody can see here, I don't know, a pizza slice, right? Or this is a pizza, right? No? So this is just an example of like how we all perceive things differently. We see things where there is a blank space, square space in the middle. But we all process information differently. And it all varies between every single one of us. So that's the most important thing that you have to know. And that's how complex the somatosensory system is. So, all right. So when talking about the somatosensory system, the first thing that I really want you to know is, and I'm going to use this as a, so we have here, this will be That's skin, okay? Here in the skin, we're going to have receptors, right? Different receptors. And the information perceived by the receptors is going to travel where? To the central nervous system, correct? This information is going to travel through the peripheral nerves, right? If the central nervous system, this could be, I don't know, your brainstem, your spinal cord, right? Most of the time will be your spinal cord. So you see here that we're going to have one neuron involved, right? And that's called the first order neuron. Do you know how many neurons are involved in this? In the sensory tracts? 3, right? So we're going to have the first order neuron. Then here, it's going to end up in the spinal cord, right? We can say we're in the CNS. It's going to stop here, right? And from here, you're going to have cell bodies that are located in the central nervous system, and the information is going to travel where? To the thalamus. Do you know the specific nucleus of the thalamus where this information is going to end? You don't need to know that. I'm just making your life difficult. But it's called the VPL, or the ventroposterolateral nucleus. All right. So this is the second order neuron. And then the third order neuron, or the last neuron, the third neuron, right, it originates in the thalamus and travels all the way where? Where? In which area? Where does it end? In the postcentral gyrus, and that area, that's where we have the primary somatosensory cortex, right? Does that make sense to you guys? So basically we have 3 neurons involved. The first order neuron originates here. Normally the information travels from the receptor all the way to the central nervous system. From there, from the central nervous system, information is going to travel to the thalamus, and from the thalamus, information is going to travel to the primary somatosensory cortex that is located in the postcentral gyrus. That's basically how the somatosensory system is arranged in series. Okay, so basically we're going to have receptors, as I mentioned to you, and they're going to like the stimuli that is going to travel or is going to be interpreted by the different receptors, they're going to travel as nerve impulses, right? We all need a certain little potential that needs to be generated, that meets a specific threshold. Once that threshold is reached, an actual potential is generated, and then the signal travels, right, to the central nervous system. If the signal is not strong enough, there is nothing actually gets and processed all the way onto the brain. Okay? So for this, you're going to need to know so that there are different receptors. Okay? And we can classify these receptors by using different ways. If we look at their function or the type of signals that they're going to transduce, we're going to have chemoreceptors, we're going to have photoreceptors, we're going to have thermoreceptors, and mechanoreceptors. Mechanoreceptors is just any, like, let's say for example, touch. It's one of like a mechanical things. Thermoreceptors, you have to relate it to thermal stimulus, right? Photoreceptors associated with light, that's the one that you're going to have in your visual system. And chemoreceptors is they're going to send different chemicals that you have in your environment, right? So here is a good table that summarizes the things that you have to know in terms of the stimulus, right, that trigger a response on the receptors. So this is something that you have to review, okay? All right, so there is another thing. There are other receptors that are associated with pain. So there are nociceptors. And when we're talking about nociceptors, I don't know if you're familiar with the term nociception. Have you heard about nociception? It's basically pain sensation. So when talking about pain sensation, nociception, we are going to need specialized receptors that are going to sense these pain signals, right? So nociceptors always related to pain. When you see the word here, nociception, nociceptors, it's always related to pain. That's very important because I think that you're also going to be tested on this, right? There are different signals that can trigger pain, right? You can burn your fingers with like very low temperatures. You can burn your fingers with heat, right? Or let's say there is like, I don't know, like an acid substance or a chemical that you touch that can also burn your fingers, right? There are, in terms of neurotransmitters involved, there are several neurotransmitters involved. The most important one is probably glutamate, because that's an excitatory neurotransmitter, right? Substance P is also involved in like modulation of pain. And also remember that there is an area of your brain where all these pain signals also travel. They're associated, some of the pain signals, they travel to your limbic system where your emotions are. And all these, like for example, the perception of pain can be enhanced by emotion, right? Or by different things surrounding the environment, right? All right, so also when expanding on receptors, we can see these receptors can deliver the information to the brain in different ways, right? We're going to have, we talked about proprioception, right? You know what proprioception means, right? So for that kind of information to send conscious information to your brain, you're going to need a specific receptor for that. And these are called proprioceptors. And where are you going to find them? Muscles, tendons, so you know where your body's positioned, right? Then we're going to have also receptors on the skin. And in the skin, those are important because there are so many thermal sensations that are going to be processed by these cutaneous or skin receptors, touch, pressure. And then we have special receptors, and we're not going to get into it, for the special senses. So if also we can look at the receptors depending on from where it comes the signals or the information. If, let's say, if we have low concentrations of oxygen, right? Your receptors are going to sense that. Let's say also if there are changes in your blood pressure, you're going to have specific receptors that are located in your carotids, in the arch of the aorta, that are going to sense these changes in blood pressure, and they're going to send those signals. So all these receptors, since they're located within your body, these are called interoceptors. And all the receptors that are that brings information from the periphery, from the external environment, these are called exteroreceptors. All right, so also depending on the stimulus, the receptors can be divided into on how adapted to this stimulus. So there are two types. There is basic and there are tonic receptors. Let me just show you the graph where I think these two are better explained. So if we have a basic receptor, you see here that there is a stimulus here. There are every single line that you see here that is being generated is an action potential. You see here that with time, these receptors end up adapting, right? And sending and decreasing the amount of signals for action potential being generated. On the other hand, if you have a tonic receptor, like for example, the one you if you have, let's say, if you have a heat stimulus, if the stimulus here is applied, since also this information travels slowly, right? They use unmyelinated receptors, unmyelinated fibers to bring that information. These are going to be slow adapting, and you see that these, this is the pattern at which the tonic receptors work. If we go back here, so basic receptors, they're going to respond immediately when there is a burst of activity, right? But they're going to quickly adapt. Tonic, they're going to maintain a high firing rate as long as there is a stimulus. Okay? These are the ones we find in pain. We already covered that. So, in terms of the things, principles that are associated with pain, or like just the signal that travels through different nerves, right? The information that can be given to a given nerve fiber can only be experienced as just one stimulus. Okay? That's very important. All right. So for the different stimuli to be generated, and like we were talking before when we were talking about the action potential generation, right, on the nerve cells, here's the same. So we're going to have generator potentials. You remember the excitatory postsynaptic potentials, the inhibitory, the little local potentials, right? They're all going to generate a gradient response. So as you can see here, there is, and we'll look at number one, the stimulus that was generated wasn't enough to actually reach threshold. And remember that all these that I gave you, do you remember the threshold for the nerve cells? 55, right? The thing here, I cannot give you a specific threshold because there, like there are so many different receptors. You saw how like they can be divided functionally. They're so different that they're going to react to different thresholds. Okay? Basically here we just need to mention that there is a threshold, and as you can see here, like the stimulus 1 and 2 they were not strong enough to actually reach threshold and then be able to generate an action potential. So if there is no action potential being generated, there is no signal or sensory transmission of the signal. Here, like when we were able to reach threshold, or let's say the mechanical stimulus, if we were putting pressure, it was strong enough to actually reach threshold, an action potential was generated, and then that signal traveled all the way up to your brain, to the primary somatosensory cortex, right? All right, I'm going to skip this because it's talking about a specific receptor that we're going to cover right now in a second. So, action potentials, as you can see here, by looking at the generator potentials that we find in the sensory system and the strength of the different stimuli, you see here that here, when there is when the generation potential didn't reach threshold, you see that there is stimuli being generated, but there is no action potential. When we were able to reach threshold, and you see here that the strength of this stimuli was double, actually, was strong enough to reach threshold, and action potential was generated. But you see when we increase even more the stimulus, right? This increase, and you see here how the number of action potentials that were generated were perfectly correlated with the intensity of the stimuli. So the stimuli, the strength of the stimuli is highly correlated with the action potential of generation. That's something that you have to be aware of. All right, so let's talk about the skin sensations. So there are specialized receptors all over the place. If I show you this graph here, you're going to see here, this is the skin. Here we have the dermis, the epidermis, right? We see that there are different cells in there, different receptors. The one that is more like in the periphery, right? It's called the Merkel disc, or just Merkel, right? These Merkel discs, you're gonna find it. The sensations that they're gonna bring to the brain, right? It's associated with texture and more than anything, crude touch, right? These Merkel discs, you're gonna find them on the fingertips and also on the external genitalia. The Merkel disc. These are associated with crude touch. Okay? Then we have here, if we look at this little circle here, we have the Meissner receptors. These minus receptors, they're going to be associated with fine touch, right? Merkel, crude touch, Meissner is going to be associated with fine touch. And more than anything, it's going to help us with what is called two-point discrimination. I don't know, have you heard about it? Did I talk about it? No? Okay. You'll know everything about the two-point discrimination. So, Meissner, where do you see them? So you can see here, like in terms of location, they're all over the skin. Okay? The next receptor is the Pacinian. You see here that they're like, in a way, they are more deeply located. These are here surrounded. You see here, there are several layers or capsules that surround this Pacinian receptor. These are associated with pressure, okay, and vibration. These Pacinian, you're going to find it in the, I'm going to write it here for you, in the dermis and subcutaneous tissue. You can also find it, this, you know that the bones, they're also covering a layer called the periosteum. So you can also find this Pacinian in the periosteum surrounding the bones. You can also find this Pacinian in the ligaments and in the intramuscular connective tissue. So Pacinian, dermis, and subcutaneous, periosteum surrounding the bones, right? The ligaments and intramuscular connective tissue. I cannot write this all because it's going to be overwhelming for you guys. All right, and the Ruffini, these are going to be associated with skin stretch. These Ruffini, I'm gonna near the folds of the skin. Hold on, of the skin where? Of the skin. Where? If these are stretch receptors at the joints, right? Does that make sense? And also, beneath the fingernails and the toenails, you can also find these Ruffini endings. But Ruffini, near folds of the skin at the level of the joint, associated with skin stretch. Right? So that's, I'm going to say the four most important cutaneous sensory receptors you're going to be tested on this. So Merkel, don't forget, crude touch. Meissner, fine touch. Pacinian, vibration or deep pressure, and the Ruffini associated with stretch, right? Skin stretch. So those are the four more important, and this is ideal for you guys. Okay? And then I forgot there are three nerve endings that are going to be associated with touch and vibration. Okay. So this is also associated. This is a good summary of what I just mentioned. So this is high. Okay? All right. So there are receptors for cold, hot, and warm receptors. They are located in the epidermis. So cold receptors, it makes sense. The temperature at which they respond, they have to be cold, around 8 to 828 Celsius, right? Warm receptors, they feel some kind of warming, right? They're gonna generate action potential. And then we have the hot receptors that are also gonna be activated at high temperatures, 43 Celsius or higher. Okay? All right, so you see here, we're gonna start talking about pain receptors. So pain receptors, what are the names for pain receptors? Nociceptors. So these pain receptors, they can be myelinated or unmyelinated. If they're myelinated, that means that the signal travels fast. So this is going to be associated with sharp pain, correct? And the pain that is persistent, it's going to be associated with unmyelinated fibers. For example, let's say now, if I cut my finger, right? the sensation, let's say, yeah, the sensation that I felt immediately to withdraw my fingers when I cut it, that was associated with receptors that transmitted that signal through myelinated axons, right? That was immediate. But then the pain that I feel afterwards, when there are all those free nerve endings exposed, right? That persistent pain travels through unmyelinated fibers. Takes longer time, right? All right. So there is also itch sensation, and that's more associated with immune mediators like histamine, right? These are associated with mast cells and basophils. These are all associated sometimes with allergic reactions. And they normally stimulate unmyelinated sensory axons. All right. Yes?
Are nociceptors also basic?
Yes.
Yes.
Mm-hmm.
And the itch?
No. All right. So let's talk about the different neural pathways that you're identifying in the somatosensory system. So I really, when I was looking at this slide, like there's a lot of information that we already covered, right? So from the outside, from the periphery, like, right, you can see here that it's carried first by large myelinated fibers that ascend the dorsal column, the synapse here, the second order neuron, where do they go? This is actually talking about these tract here called the dorsal column medial lemniscate pathway. So in the somatosensory system and in your textbook, there are only two pathways that are ascending. One of them is the dorsal column medial lemniscate pathway. This pathway here is associated with, I'm going to write it down, 2-point discrimination. 2-point discrimination. What else? Vibration. And conscious proprioception. So the dorsal column medial lemniscate pathway is associated with 2-point discrimination, vibration, and conscious proprioception. So generally speaking, and this is a concept that I really want you to associate with, right? So we have here the spinal cord, right? You know that there is a spinal cord. This is the gray matter, correct? Yes? So we have here, phylogenetically speaking, I'm going to say that's more primitive and more modern, right? Here, you see here that there is what is called dorsal column. You see it here, this space here, right? White matter that is behind the dorsal horn. Right? You see that? This dorsal column, and it's called dorsal column, like in terms of, these are more the white matter and all the atoms that are here, they're in terms of myelination, they're myelinated. They're going to carry less primitive sensations or more modern. You can see this as a big freeway highway, like speed highway, where signals are going to travel really fast. And here, through this dorsal column, only sensory information travels. So what you see here in the dorsal column is all ascending axons that are associated with the sensory system. So here in this dorsal column, this is where you're going to see, right, that the information is going to travel, that it's going to be associated with 2-point discrimination, vibration, and conscious proprioception. So again, this is like a modern highway, very fast. There's more myelin here than when compared to, I'm going to change the color of this, to, okay, I'm going to use green. All right. We have what is called here the anterolateral system. This anterolateral system is more like the sensations that travel through them are more primitive. So this is the green, anterolateral system. Here in this anterolateral system, as I mentioned to you guys, the information that is going to travel through them is more primitive. So what do you think? What kind of sensation do you think that we're going to be able to sense here? Pain, temperature, these are primitive sensations, right? What else, like touch, pressure? Those are more primitive, right? And of course, that information is going to travel more slowly because this anterolateral system is more primitive. There is less mining than the speed highway that we have here in the dorsal column, which is more moderate, right? Yes? All right. So now that we have an idea of how, let's say, this and here I forgot to mention that in the anterolateral system, you're going to have ascending and descending fibers. So motor and sensory tracts are going to travel through this anterolateral system. When we only see here that in the dorsal column, we only have ascending fibers. Okay? Is that understandable? Yes? No? All right. So in the speed highway, the motor, the dorsal column here that we have here, right? We're going to have sensation coming from proprioceptors. Remember that through this dorsal column, medial and distal pathway, there is conscious proprioception. It's transmitted through this, right? Conscious proprioception, vibration, and two-point discrimination, right? We have different receptors here. The information you see here, there is first order neuron. It's going to travel and it's going to end up in the central nervous system, and it's going to immediately go, right, and travel, or you actually don't see it here, right, through the dorsal column, right? The fibers are going to go this way, and they're going to travel on the same side, and they're going to reach the medulla, where they're going to terminate into nuclei called, don't get like the grassi and cuneate nuclei, right? These are associated with the gracile. It's going to have all the information associated with the lower extremities, and the more lateral or cuneate is going to be associated with the information that they process from the upper extremities. So, do you remember, for example, do you remember the homunculus, how they were all distributed? No? Do you remember, like here in the middle, what were the structures that were represented here in the middle? No? The legs? No? And here we have the face, you remember? The fingers, right? But here in the middle, do you remember that there were the legs, the lower extremities? The lower legs, right? So, if you see this, right? If you see here that immediately, like the information that comes from this gracile nuclei that I mentioned to you guys brings information from the lower extremities, where do you think that they're going to terminate? They're going to, you see here that they're immediately located just like